Okay. All right, I'm going to share my screen for you here. Maybe never figure out the buttons to press. All right, you can see my hand, right? Okay, so we're looking at a problem that says, considering that calcium chloride is a strong electrolyte, what is the molarity of the chloride ions that you would find in a solution? All right, so we're dealing with calcium chloride first off. So we're dealing with calcium chloride is going to be my properly translated formula. All right, and then it says, well, we're going to have 8.99 grams of him. All right, and it wants to know, and we're going to prepare a solution that contains 150 milliliters. All right, so there's my info. All right, and we want to know the molarity of chloride ions. So the question is, what is the molarity of the chlorine ions? So that's what we're trying to solve right there. So let's find the molarity of the entire compound. And then, like you said, this does refer to that last question where there's an extra step to get chlorine by itself. So if I look at my equation that I'm going to use, all right, right now I don't have moles. I have grams, but that's an easy fix. So I'm going to go ahead and take 8.99 grams of calcium chloride, and we'll convert it to moles, so then we have something to work with. All right, so we're going to go from grams to moles of calcium chloride. Make the diagonals match. All right. My conversion factor states that 1 mole is equal to periodic table grams. So we'll need to add up 1 calcium plus 2 chlorines on the periodic table. If you add it up, it's 110.98. So I'm going to, exactly, so multiply 8.99 times 1 divided by 110.98, and I'm going to get 0.0810. And now we've got moles. Hooray. All right. So we can start to use our equation now to find molarity. So I'm going to go molarity equals my moles of 0.0810. And then if I go back to my original volume here, well, that's no good. It needs to be liters. So I'll slide the decimal to the left 3 times, and it becomes 0.150. 0 actually. And now I can get a molarity by dividing those numbers of 0.540. All right, it's moles per liter. So that's a preliminary answer, and for your other problems in this assignment, most of them do stop there. However, we are looking for the molarity of just the chlorine ion. So I need to realize that once the calcium chloride is dumped into the solution, it breaks up into these. And there's actually twice as many. So in order to solve the answer, I'm going to multiply by 2. And so my value here, my 0.54 times 2, is going to finally equal 1.08 molar.